So I'll ask you to do conversions. Am I going to do conversions? No, because we're not babies anymore, yes? You are going to know how to do this because we did 1,000 at the beginning of the semester. Yes?
Nope.
Now, did I tell you what pressure was? Huh?
No.
I did not?
Las clases minhas vou, like, gay, Charles,
Are you sure because you don't want to be cold?
Avogadros number, yeah. You didn't do anything with
Okay, let's do a problem. Okay, very quickly.
V1 and the other.
Very quickly. I am not going to do 20 of these problems, okay? There's many laws. You can do a little math, yes? It's called solving for stuff. Now, which law is this?
The ideal gas one.
This is pressure, volume.
Isn't that pressure value and then isn't it V1, P1, and V2, P2?
No, it's,
Temperature. Yes, Charles. Yeah, Charles.
Okay, so kind of no idea what happened last class, right?
Charles.
That's what the message I'm getting for you. This is Boyles. This is Charles. This is Gay Lussac. And this is Avogadros. Okay? There is a P here, there is a V here, there is a T here, there is an N here. That's the way we did it.
Right.
This is about, what's this here? Volume. And this is temperature. I don't know anything else, but you have a volume for this temperature, and then you have another temperature, and I am asking for the volume. That could be something else, but you have 3 things out of the 4 things. So here is V on the top, yes? V1, T1, V2, T2. Now, it could not be in degrees Celsius. You got to change this to Kelvin. Was that clear from before?
yeah.
You got to change it to Kelvin. So how simple is this? Look, this is what I'm going to do. This is like concentration, right? Remember M1, V1?
Yeah.
Or C1, M1, but whatever. Here's V1. Which one is V1?
15 minutes.
Okay, let's put that. 15 liters. And what is the temperature that
25.
belongs to this volume?
25.
25 degrees. But I'm not going to put 25, yes? I am going to put 25 plus 273. Because I need to convert it to Kelvin. And this is going to be equal volume 2. Do I have the volume 2? No, that's what I'm looking for. Divided by the temperature at this volume that I am looking for, which is?
75.
So it's 75 plus 273. And what I'm going to do is solve for this. You solve for it, and what you get is 15 liters times 75 plus 273 divided by 25 plus 273. with your incredible mathematical skills, what would you do? Would you cancel this 273 with this 273?
No.
Hello?
If you want.
With your mathematical skills?
Yes.
Your calculus, you took calculus 3 already, yes? Can you cancel the 273 with 273? Never.
No.
Ever,
No,
ever.
I'm good at that.
I said no, but everyone started to laugh.
You said yes.
I said no first, and everyone started to laugh.
Exactly, and then you said yes. In which case, you just
Why you
guessed the
follow
right
me? Come on.
one. You just guessed the right one, girl. That's all there is to it. You should drink a 10-50.
Kalichna is healthy.
Look, this is how the beer is called. 10. There you go. That's what they call it. I don't know how a Russian come up with that name. 10-50.
It's like, it sounds like slang.
That's right. So, what is this, guys? Quickly.
17.52.
17 point?
52.
Let's just leave it at 17.5 to what? Liters? 17.5 liters? Yes or no?
Yes.
17.5 liters. Does that make sense? Russians are going to be famous. Guys, does that make sense? Yes or no? Because the volume and the temperature are directly proportional. What that means is, if you increase the temperature, the volume does what? Increases. Okay? Now this is called the combined gas law. Okay? The combined gas law is like this. The combined gas law is missing what? What is it missing? Moles. Okay? So the combined gas law does not have moles, but it has everything else. Let me see if I can find that boat. Hmm? No, man. What equation? Okay, let's do this problem, okay? I had one that was good for an air bubble. Okay, a balloon with a volume of 6 liters. Okay, a balloon with a volume of 6 liters at sea level. So let's say balloon. That's not how you spell balloon, right? Okay, so balloon, is that how you spell balloon?
Two O's.
You guys English majors? Who's an English major in here? Volume of 6 liters at sea level.
Chicken's gonna be famous.
Oh yeah. So the volume of the balloon is 6 liters at sea level with that. And the temperature is 22 degrees Celsius, is allowed to go up into the sky. Fancy word, ascend to a pressure of 0.45 ATMs. And a temperature of minus 21 degrees Celsius. Damn, that's cold. That's in Canada, right? It went all the way to Canada. What is the volume of the balloon? So what is this? Is that Boyle's law? That's not Boyle's law. It has three things, yes? It has volume,
Volume, temperature, and pressure.
pressure, temperature. Okay? Let's see, so far, I don't know what this is. And then it talks about another pressure. It talks about another temperature, it's asking you for volume. This is combined gas law. P1, V1 divided by T1, P2, V2 divided by T2. Yes? I just plug in this stuff. What's the pressure? 1 ATM. Damn, you hit it. Don't be abusing animals. V1. You can eat it when it grows, but not now. You can make it a chicken wing right now.
Chicken legs.
What's the volume? What's the volume?
6 liters.
6 liters. This is the balloon going into the sky, okay? When you guys have released balloons into the air, yes? And what's the temperature? It's not 22. I don't even want to put 22 down there. What is it? 22 plus 273 is
295.
275?
295.
295 what?
Kelvins.
295 Kelvin. There you go. I put that there. Second pressure. What's the second pressure? 0.45. The pressure is lower. Yes? Because there's less air up there. So
Do we have to change it to torque?
we can leave it in ATMs.
We can leave it at 10.
Yeah, because it will cancel out. So what's the volume here? We don't know it. So what am I going to put? V2. And I'm going to divide by what I do know, which is that temperature is minus 21. And this would be confusing for you. 273 minus 21 is? Which one? 252?
Kelvins.
252 or 253?
252.
Very nice. You guys put that in the calculator, yes?
Yes.
We do not want you to use your mind here. 252, what you said. And now what? I am going to solve for this. 1 ATM multiplied by 6 liters divided by 295 Kelvin. I am going to multiply 252 here, multiply there. It's going to cancel on that side. I'm not even going to put that. There you go. The Kelvin cancels with the Kelvin. And now this 0.45, divide here, divide on the other side. That cancels. And I just write this on the bottom here. So what happens to the ATMs? ATMs cancels with ATMs. The only unit I have left is what? V2. Liters. What is it?
Kelvin's canceled as well, right?
Yeah, I canceled it. It doesn't look like it, but it is. Machina, speak. What's the answer?
Is this me up to 5.4?
Huh?
Is this me up to 5 minutes? What?
Come on, guys.
11.4.
11.4?
Yeah.
11.4 what? What happened to the volume?
It increased.
It increased, right? Because at a higher pressure, the volume is smaller, right? As the temperature went down, so the volume got smaller. But the pressure got smaller too, so the volume got bigger. You expect the balloon to be inflated at that volume? Maybe the balloon explodes. Yes? Or do you think it continues going up until it leaves the earth and goes to the moon? What do you think? Okay, don't worry. Let's talk about something called STP, standard temperature and pressure. I'm done with the laws. There are some that I didn't do, but you can do them. Don't tell me you didn't do a problem like this in class. STP, write it, standard temperature and pressure. Standard temperature is 0 degrees Celsius. Standard pressure, 1 atm. So under standard temperature and pressure, there is a volume, and that volume is called the molar volume. And the molar volume means 1 mole is the amount of moles you have, occupies a volume for whatever gas, and the volume is 22.4 or 21.4, who knows? Didn't you guys take a lab?
22.4. But that's for water.
For water?
No.
It's not for water, it's for every gas. How much is it?
22.4.
22.4? Okay, before the end of the class, I want the chicken girl to take the chicken and put it right in front of the camera. So I can give a shout out to all the chickens. So,
You gotta do that.
1 mole is equal to 22.4 liters. That's called molar volume, yes? Molar for 1 mole, and volume is all gases at those temperatures occupying the same volume. Hello?
Yeah.
Okay. So we have the ideal gas equation, yes? PV is equal to nRT. Yes, this is called the gas constant. I want you to calculate the gas constant.
R is a constant, 62.4. Door.
What happened?
R
There's
is
like 2 of them.
R is a constant and 62.44.
Guys, I'm not asking you how much it is. I'm asking you to calculate it based on what I just gave you. Solve for R, plug in the numbers. No, it can't be 0. Because this temperature, you have to change it to Kelvin. Right? So this is 273 Kelvin. So if I solve for this, because we don't have a lot of time, okay? This is the initial equation I gave you at the beginning, yes? So you put the pressure in there. What's the pressure? 1 atm. What's the volume? 22.4 divided by n, which is 1 mole. You see it or no?
Yes.
1 mole. And divided by
273.
temperature of 273. What's that equal to?
0.082.
0.082.
1.
To
Or
1 or
0.5.
0.6?
0.05.
It just goes 006, but.
It's 0.0820.
Okay, you're confusing me. I have an attention deficit.
0.5.
I don't know, you have a calculator, what, you think I'm a mathematician?
0.08205.
That was 8
205.
Okay, that's where the gas constant comes from, okay? Yes? The gas constant comes from STP.
So it's a door multiplied by liter, I mean the units.
Yes, the
R.
units on it, the
Door
units on
multiplied
it,
by liter
are-
divided by mole Kelvin.
ATMs per liters per mole Kelvin.
So nothing comes.
This is called ATM liters divided by moles Kelvin. Everything is not called per. You want to learn how to derive, just, okay, it's molecular weight. This is molecular weight. This is molecular weight, this is density, gas constant, temperature, and see if we can do a problem here. Tell me, what does that equation tell you about?
The weight of a mouse.
It tells you something about molecular weight and the density of a gas, yes? The higher the density, the what the molecular weight? The greater the molecular weight. Or the greater the molecular weight, the what the density? The greater the density if you are a specific temperature and pressure that doesn't change, yes? Yes or no?
Yes.
So you can tell when a gas has a higher molecular weight based on the density. So if I give you the density of a gas, and I give you the gas constant, and I give you the temperature and the pressure, and you calculate the molecular weight of this,
You said the greater the density, the higher the molecular weight?
no, I want you to look at it and you tell me. I mean, these two are on the same side, yes? They are directly proportional. So this one gets big, that gets big, yes? What? This class is over at one time?
15 minutes.
I don't feel like doing this problem.
Really?
Okay, all right, so let's do it. We're gonna stay after class today. I don't care. We're gonna leave. 31 degrees Celsius.
Will kill us.
31 degrees Celsius, the density is this,
After this class straight.
grams per milliliter. And
Is that 997?
997, yes. And the pressure is 1 atm.
Professor, what'd you put there? Grams over what? Milliliters?
Milliliters.
Okay, that's
Yeah,
We're gonna use the previous R constant.
yes, the ones that had liters and ATMs.
That is the problem. That is the problem. Now you have to find a solution.
Maybe let's
So
make
we're
a
looking
few
for molecular weight.
What?
Maybe let's confuse it. We can if you have a time, and we can repeat.
Okay, guys, what do I have to do to this? Change it to
Kelvin.
Kelvin, okay? Here's the density. It will be in grams per milliliters. And here's the ATM. The gas constant is in what?
18 on liters or on moles.
It's in liters, so I gotta change the milliliters to liters. Okay? That's it, just a conversion, okay? And then after that, you multiply all of it together and you get the molecular weight. I'm not gonna do it. Dalton's law.
Wait,
Okay,
sorry,
you
what-
do it and you come see me.
What do you have to convert to milliliters?
You want me to tell you the molecular weight?
You have to convert milliliters to liters.
Yeah, you have to convert density.
79.7. No.
Whole point is to find it.
Molecular
You just
weight.
give us the answer.
I'm giving you the answer, so when you do it, this is what you're expected to do. Dalton's law, it says that the total pressure is equal to the partial pressures of the gases.
It's chapter 5, right?
Huh?
So we can print it out.
Total pressure. So the total pressure is composed of the partial pressure, partial because they're part of it. Partial pressures of gas 1 plus the partial pressure of gas 2 plus gas 3 plus whatever else is there. So if I tell you that a gas has a partial pressure of 5 ATMs and another gas inside of this tank has 7 ATMs, what is the total pressure of this?
12. 5%.
Yeah, I made it too difficult, so the numbers were too difficult for you to do the calculation in your head. Okay? I want the total pressure. What is the total pressure in a tank if the partial pressure of N2 is 2 ATMs and O2 is 4 ATMs.
6.
Okay? So it would be total pressure is equal to the pressure of N2 plus the pressure of O2. Okay, so 6 ATMs, yes?
That's a hard problem to plug in.
They're all that easy, okay? Okay, effusion and diffusion. Diffusion is the movement. Okay, you guys finish whatever you're doing.
Hold on.
What is that, sir? After total?
6 ATM.
Oh, that's total. No, I wasn't 100%.
Yeah, you can't read?
No, I mean, you're.
It's very clear handwriting, okay?
I meant to say.
This is P total equals 6
It
ATM.
was 6 swords. Wow.
Total.
That's Garcia's language.
That's right, man. That's how we roll.
What's the under pressure language?
Effusion and diffusion. Diffusion. When no.
The
I don't want you to write down. I want you to listen with your ears.
Grasp the concept.
Diffusion is when a molecule has to go from one side of a container to another side. As it goes from one side to another side, what does it have to do? It has to collide against a whole bunch of other ones, yes? Yes or no?
Yes.
So diffusion is the movement of molecules through a medium from one side to another side. And I think you did an experiment in the lab that you put a little bit of a little piece of potassium permanganate, yes? Hello?
Yeah.
And the potassium permanganate is purple, so you saw that it started moving. It's called diffusion. Now, effusion Guys, is that clear what diffusion is?
Movement of molecules from one medium to another.
No, not from one medium to
One
another.
side to another.
From one area to another area, from one side to another side, in the same medium. Effusion is the escape of molecules through a narrow hole.
Escape.
So, if you have a balloon,
This is almost
this
like
balloon has
Seed
a
pack.
gas inside, yes? And the gas, have you ever seen how balloons get deflated after some time?
Yeah.
What happened? Why does it get deflated?
Because it's losing,
Because the material has holes in it, right? And once in a while, one of those molecules will go through it, through that hole. And eventually, when enough of them escape, then the balloon gets deflated and deflated. Okay? That's called effusion. Okay?
So it's the escape of molecules going through a hole.
You can call it like that. Let's talk about acids and bases. I'm going to give you the definition only, okay? Did we have strong acids and bases here already?
Yes, we gave it.
And we got it.
And we have in a second test.
We did?
You gave us certain
Kind of.
bases, but you gave us all the acids.
Yes. we
Did I tell you that they were called Arrhenius acids?
no.
Yes, you did.
You just said it.
You just told us the list of strong acids and.
Okay. Here is an Arrhenius acid. This is a definition. When you get to 1046, you're going to have the rest of them. But Arrhenius acid, it is one that increases the concentration of H+. The brackets mean concentration. And this means increase, yes? So an Arrhenius acid, what does it do? Increase the concentration of H+. Okay, and an Arrhenius base, what does it do? Increase the concentration of OH minus. This is a definition. What are examples of acids that I gave you before? Those are Arrhenius acids. HCl, HBr, HI, H2SO4, H,
So all strong acids.
NO3. Yeah,
HCl03 and HCl04.
yes. And bases are things that are metal hydroxides. Sodium hydroxide, potassium hydroxide, calcium hydroxide. Because when you dissolve the hydroxides in water, what do they form? OH minus, yes?
So those are strong acids. So it increases the concentration of the base.
Okay, put the chicken in front of the camera. Go ahead, I'm serious. Go ahead.
Do it!
No, you do
I don't touch nothing.
it. Maybe that thing has rabies, man. Be careful, it will bite you.
Professor,
Hurry up, I want to turn it off. I want to turn the thing off.
in the second exam, you have HF as a weak acid.
Yes, 8.
Perfect, yeah, perfect. There you go.
Put it closer.
Get it super close to the
Good, put it closer, closer. Close enough. Bye, bye. See you later.
See you later.
Outstanding.